Good morning. I am Professor Edson. I have created this series of lessons to teach you how information is represented in digital computers. The lessons are narrated in English. However, if English is not your native language, you can enable YouTube's automatic subtitles. For instance, you can select Auto Translation into Portuguese, my native language, and the subtitles will appear in Portuguese, as demonstrated here. Welcome to this video series. I hope you enjoy it.
Greetings. In this lesson, we shall delve into the fascinating world of how numbers are represented within digital computers. More specifically, we will explore how various forms of information, such as numbers, text, sounds, images, videos, and other types of data we interact with daily, are encoded and managed in a computer system. Let us embark on this enlightening journey by beginning with a brief history of numbering systems. Shall we begin? Throughout history, countless methods of counting and numbering have been devised and utilized by different cultures. In this lesson, we will explore the contributions of a man named Leonardo, who authored one of the most influential books in the history of humanity. He lived in the region of Tuscany, which is today part of Italy. But not that Leonardo, not Leonardo da Vinci, the great artist and polymath, who was born near the town of Vinci, close to the city of Florence, in the year 1452. Instead, we will turn our attention to another Leonardo, who lived about 300 years earlier. He was born in 1170 in the city of Pisa, approximately 54 kilometers from Vinci. This Leonardo is known as Leonardo of Pisa. Like his father, Guglielmo Bernaccio, he was a trader and merchant, traveling extensively across Mediterranean trade routes. His experiences exposed him to diverse cultures and ideas, particularly in mathematics, which profoundly influenced his work. This life of exploration earned him the nickname Fibonacci, a contraction of Filius Bernacci, meaning son of Bernaccio. Now, let us delve into Fibonacci's extraordinary contributions to humanity. But first, we must briefly explore the fascinating evolution of a crucial branch of mathematics, the processes of counting and the use of numbers. Throughout history, countless systems of counting and numeration have been proposed. To begin our discussion, let us imagine ourselves as a primitive people, one that has yet to conceive of numbers. Now, which number do you think was invented first? Any guesses? Interestingly, many believe it wasn't the number 1. The reason is fascinating. When observing a single object, early humans might not have grasped the concept of plurality. In fact, many suggest that the very first number conceived by humanity was the number 2. Let me share with you an intriguing story. Some time ago, on a remote island in the Pacific, researchers encountered a highly primitive tribe. This tribe used an astonishingly simple counting system. They recognized only 3 numbers, 1, 2, and another that translated roughly to many. Curiously, their word for many was identical to their word for hair. Whenever they referred to many, they would perform a distinctive gesture, raising both hands slightly above their heads and swiftly lowering them, as if mimicking the movement of hair. Now, how might such systems have evolved over time? One of the oldest known records of numeration comes from the ancient Lebombo bone, dated to 35,000 years ago. But how might early humans have counted in their daily lives? Let us explore some reasonable hypotheses. One natural method was the use of tally marks, where each mark corresponded to an object being counted. For example, 1 loaf of bread, 2 loaves, 3 loaves, and so on. However, as the number of tally marks grew, visually discerning the total became increasingly challenging. To address this, a clever solution emerged, grouping the marks in a more structured way. One familiar example is the system often depicted in films about prisoners marking the days of their confinement. In this system, after counting 1, 2, 3, and 4 vertical marks, the fifth mark is drawn diagonally across the others, creating a recognizable pattern. This grouping of 5 made it far easier to perceive larger quantities at a glance. A similar method involved arranging 4 tally marks into a square, with the fifth drawn diagonally through the middle. This creates easily recognizable groups of 5 objects. Now, let's try something. Take a quick look. What number do you think this represents? Got it? Correct. It's 34. Here's a question for you. Why do we naturally tend to group things into 5s? The answer becomes clear when you look at your hands. Groups of 5 are intuitive because we're so familiar with the number 5. It's quite literally at our fingertips. Some counting systems also group objects in 10s. And why might that be? Exactly. 2 hands together naturally form a group of 10. Over the millennia, systems of counting have evolved in fascinating ways. Some persisted for centuries, while others faded into obscurity. Examples include the numbering systems of the Sumerians, the Egyptians, the Mayans, and many others. At a certain point in history, however, the Roman Empire rose to dominance across what we now call the Western world. With this dominance, Latin became the common language, and along with it came Roman numerals, a system you are likely familiar with. The Roman system begins with 1, represented as a single tally mark. 2 is written with 2 marks, and 3 with 3. Typically, Roman numerals are repeated up to a maximum of 3 times. Before we look at the number 4, let's consider 5. As many of you will recall, the number 5 is represented by the letter V. Now, what about 4? It's written as IV, A, V, with 1 tally mark to its left, signifying 5 minus 1. And so, we have the numbers 1 to 5. What about 6? It's written as V, I. 7 is 7, and 8 is 8. How, then, do we write 9? It's IX. 10 minus 1. And 10, that's X. From there, the sequence continues, 11, 12, 13, and so forth. Now, let's try something a bit more challenging. Write the following number in Roman numerals, 1994. Take a moment, pause the video if needed, and give it a go. Finished. The correct answer is MCMXCIV. As you can see, Roman numerals are not particularly difficult to understand. However, they are incredibly inconvenient for more complex tasks. For example, with some effort, most of us could manage addition or subtraction using Roman numerals. But imagine trying to multiply, divide, calculate powers, or even work with fractions and decimals. Now think about applying Roman numerals to sophisticated fields like number theory, cryptography, or advanced mathematical operations. The truth is, working with Roman numerals would be incredibly cumbersome. In fact, they would have significantly delayed mathematical progress. At this point, let's take a deep breath and prepare to discuss an event that arguably had the greatest impact on the development of Western mathematics, and eventually, the entire world. Let us now delve into the marvelous work published by the merchant and mathematician, Leonardo Fibonacci. Leonardo of Pisa, better known as Fibonacci, was born in 1170 in the bustling city of Pisa, one of the most vibrant maritime republics of the time. His father, Guglielmo Bonacci, was more than just a merchant and trader. He also served as a diplomatic representative of the Republic of Pisa in the city of Bugia, located in what is now Algeria, in North Africa. This position connected him with diverse cultures and knowledge, creating the perfect opportunity for his son, Leonardo, to travel and study in distant lands. These journeys proved pivotal in shaping Fibonacci's intellectual development. During his time in Bugia, he encountered the Indo-Arabic numeral system, a concept that would revolutionize mathematics in Western Europe. Fibonacci is widely regarded as a towering figure in the history of mathematics. Many historians describe him as the most talented Western mathematician of the Middle Ages. However, his greatest impact came not from an invention of his own, but from his unique ability to introduce, adapt, and popularize a system he encountered during his travels. This system, the Indo-Arabic numeral system, was developed by peoples in the region that is now India between the 3rd century BCE and the 6th century CE. Renowned Indian mathematicians such as Aryabhata and Brahmagupta were pivotal in advancing the concept of zero and the decimal positional system, the very foundation of the system we use today across the globe. Between the 8th and 9th centuries, this knowledge was translated and refined by Arab mathematicians like al-Khwarizmi and al-Kindi, who recognized its immense value and applied it to practical fields such as commerce, astronomy, and science. This rich cultural exchange enabled the widespread dissemination of the system throughout the Islamic world and eventually into Europe. For this reason, the numerals we use today are called Indo-Arabic numerals, in recognition of their Indian origins and the Arab scholars who contributed to their refinement and dissemination. Fibonacci's genius lay in his ability to communicate, contextualize, and adapt this system for medieval Western Europe, which was still reliant on the cumbersome and inefficient Roman numeral system. At the time, Roman numerals made calculations and record-keeping particularly challenging, especially for commerce. Fibonacci recognized the transformative potential of the Indo-Arabic system and showcased it in his masterpiece, the Liber Abaci. First published in 1202, the title of the book translates to the Book of Calculation, not the Book of Abacuses, as is sometimes erroneously interpreted. In the Liber Abaci, Fibonacci demonstrated the superior efficiency of the Indo-Arabic system for arithmetic, solving practical problems such as currency conversions, interest calculations, and the division of goods. These real-world examples made the book indispensable to merchants and administrators of the time. Some historians regard the Liber Abaci as one of the most influential texts in Western history, especially in mathematics. A few even argue that it is second only to the Bible in historical impact, due to its role in shaping scientific and economic thought. The impact of the Liber Abaci was so profound that it is often credited as the starting point for Europe's transition to more advanced mathematical methods, paving the way for developments in science, commerce, and economics during the modern age. Now, shall we delve into this fascinating numeral system that changed the world? In the forthcoming video of this series, we shall delve into the fascinating world of the decimal positional system, introduced to the Western world by Fibonacci. In the episodes that follow, we will embark on a journey through a range of concepts, unveiling how information is represented and processed within the intricate realm of digital computers. See you in the next video.